Hello guys, today we'll be solving this LeetCode number 27, that is remove element. And so what this problem really mean is that we are given an integer array nums and an integer value. Remove all occurrences of value in nums in place. So uh, we have to manipulate the values in place without creating a new array, and the order of the elements may be changed, then return the number of elements in num which are not equal to value. So we will be given an array nums and a value val. So consider the number of elements in nums which are not equal to val bk. To get accepted, you need to do the following things. Change the array nums such that the first k elements of nums contain the elements which are not equal to val. The remaining elements of nums are not as important as the size of nums. And finally return k. So let's take a look at this example number one. The example number one, the in the example number one, we can see that we are given an input. Nums is an array that contains 3, 2, 2, 3, and the value is 3. So the given output is 2, and the final nums is 2, comma 2, and the remaining values aren't that important. So what does this mean? So we have to remove the value 3 from this array. From this array, there is this 3 and this 3. And what remains is this 2. This 2, 2. And so let's move on to the example number 2. So we are given nums 5 and value is equal to 2. So what does this question, what do we have to do here? So basically we have to remove the 2's from this list or array nums. So what is the final answer? That is 0, 1, 3, 0, 4. And what is the count? 1, 2, 3, 4, and 5. So here 5 is the answer, and then this is the result. And so how is this done? So this is done by using in place shifting of the values. That is, if this comes here, then this comes here, and then this comes here. For this, we will have two approaches. That is, one is the first and fast and slow pointer, and another one is two pointer approach. So first of all, let's go on with the mm, fast and slow pointer method. Okay, so let me just show you an example. So this is the given code or the example. So basically what it does is that we will just put a pointer key is equal to 0, and here then we will just loop through the whole and we will loop through the whole array, and while looping through the whole array we will if the value of the array if the value of the array there is 3, if 3 doesn't equal to 3, then we will just swap it. If this 3 doesn't equal to 3, then we will swap it. But for now, 3 is equal to 3, so we'll just skip and we'll skip to the next element, that is 2. So 2 doesn't, so the next element or the next element of 3 is 2. So 2 doesn't equal to 3. So we will now swap the values of this 3 and 2 here. So this becomes, so the array becomes is equal to the array is equal to 2 comma 2 comma 2 comma 3. So this is the how our array looks like now, and our index is at the third index, that is this our i's here, and the value of array I here is 2, so we just skip it and move on to the next. Then next there is 3. So 3 is equal to the value that is 3, so we will skip it and we will swap it, but as we can see that there is no value next to 3, so we will just end our loop here. So this is basically the first solution. So let's code it up. So let's write the code. Um, First, let's put k is equal to 0. So k will be checking the length or how many elements are present in our array. That is not the target value. And k is equal to 0. And so for I, or let's say for elements, elemen, yes, for elements in range len of nums, and for elements in range of len of num, this means that we'll iterate through the whole array. And if nums of elements doesn't equal to val, then what we will do, we will swap it. Nums of k is equal to nums of elements. So this by this we have swapped the values of the next value to the previous value. And then we'll just increment k plus equals to 1, and then we'll just return the value k. And so we can see that our test cases have been accepted. Now let's just submit it. Now we have successfully submitted, and now let's move on to the next approach, or the second approach, that is swap from the n. So let's just take a look at it. Okay, so let's move on with our approach number 2, that is swap from n. So let me discuss the how we will proceed. We will proceed it by taking two pointers, that is I and n. I is pointed at the first index, and the n is pointed at the last index. So how we will approach with our code is that, first of all, we will check if I is equal to value number 2. If I is not equal to value number 2, then we will increment our I. We'll increment our I uh, to the second index. And so then we will check if the index I is, if the value index I is equal to value, that is 2 here, and it is not equal to 2, so we will increment I to the next index. And here the next index is equal to, and the next index is equal to 2, so we will decrement our n, that means shrinking our window size to the last second element. And so, and then we will swap the value of 4, and we will swap the value of I and n. That is 4, this will be 4, and this will be 4. We will not swap, we will just put the value of 4 here. And so we will just move on to our next value, next index, that is 2, and then 2 is equal to 2 again here. So we will shrink our window, that is to 0. And so 2 will become 0. And then let's move on to our next thing, that is I will be uh, I will be at 3, and I'm sorry, I cannot. Okay, I will be at 3, and n will be at 0, but I doesn't equal to 2, so we will just keep it as it is. And so we will keep on checking it, but we will just end our example here. And the time complexity of our approach will be O of n. Why O of n? Because we have to iterate the whole array. So the time complexity is O of n, and the space complexity is O of 1, because we are not using any uh, we are not using a new array. Okay, so now let's code it up. So we'll just use our I is equal to 0, and n is equal to the len of nums. And so let's start our looping while I is less than n. While I is less than n, if nums of I double equals to value, then what will happen? We will just decrement n minus equals to 1. We will decrement 1, and we will swap the value of nums I is equal to nums of n. Else, what will happen if we don't if the value I is not equal to the value? So we will use I plus equals to 1. We'll increment I by 1. And what will happen at last? We'll just return the value n. And so all test cases have been passed. So now let's just so this is our submission and we have passed all the test cases. Our run time is 0 ms and just we beat 0% of the